Before we ever begin taking notes on Lesson 13.4, let's make sure that your paper is headed correctly. On the first line in the left-hand corner, you want to write today's date. I do not have today's date written because the day I'm making this video does not match the day you're taking notes. Please make sure that you fill this out correctly for yourself. Across from the date, in the right-hand corner, please write 4 things: your first name, last name, number, and class letter. On the following line, please write today's lesson number. The lesson comes from Chapter 13, and it's Lesson 4. Then skip a line, and against the left-hand margin, go ahead and put number 1 for the first question. Let's also go ahead and look at what we're going to be working with in this lesson. So in the top left-hand corner, this indicates this is Chapter 13 and Lesson 4. And the title is Volume with Fractional Edge Lengths. So we still have a rectangular prism, and we're still trying to calculate its volume. In other words, how many cubes could fit inside this shape? The formulas are going to be the same as those we used when we didn't have fractions. We're still going to focus on the length of the prism, the width of the prism. Together, those would make the area, and then we would expand upward to include the height. The only difference in this lesson is that the edges are not whole numbers. Rather, they're fractions. Let's begin in our text by taking a look at number 1 and the instructions for it. The instructions say that for problems 1 and 2, tell how many of each size cube can fill a 1-inch cube. And the number 1 says the edge is 1/3 inch. Whoa. The first time you read this problem and these instructions, you may be thinking, what? So I'm going to take a look at the examples in the top of the textbook. On the second page of the textbook gives a great description. We are going to be given a 1 yellow cube as represented here. Then we're going to be given smaller green cubes, and we're trying to figure out how many of them would fit in the one big yellow cube. So when I go back to looking at number 1, I'm going to be given 1 cube. So I'm thinking that's the yellow cube. My small green cube, each dimension, each length, width, and height measurement is 1/3 inch. So I'm trying to figure out how many cubes of this size, these green cubes, will fit in the one big yellow cube. Now, because of how I had to look through the textbook to understand the problem, do you notice how I just figured that out? It was by visually seeing it. What I'm going to do then is I'm going to decide that mathematically using notebook paper is not the best way to start by figuring out this problem. Remember, I figured it out as the teacher by seeing it visually. So to answer this problem, I should probably attempt it visually as well. So I'm going to set my notebook paper aside, and I'm going to switch to something called isometric dot paper. Now, when I looked at number 1, I'm thinking I need 1 large yellow cube, and then the little green cubes each have sides of 1/3 inch. That 1/3 is my clue because of the denominator of 3. So what I'm going to do is I'm going to go with the denominator of 3, and I'm going to start by drawing the big yellow cube. The height of that is going to be 3 lines long. Here's what I mean. So I'm going to go 1, 2, 3. That's the height of my big yellow cube. And I got the 3 because the little green cubes are 1/3. So I use that denominator to choose how tall the yellow cube is going to be. Now I'm kind of looking at this cube sideways, and you'll begin to see it form as I draw it. A cube, all the sides and dimensions are the same. So now I'm going to go diagonally. 1, 2, 3. And I'm going to go diagonally on the other side just the same way. 1, 2, 3. I don't know if you can see it yet, but what I've done is I've drawn the height 3, the length 3, and the width 3. But I've got to actually make the cube, so I'm going to keep going. From here, I need height of 3. 1, 2, 3. I need it on this side as well, a height of 3. 1, 2, 3. Now I'm going to connect some of those vertices. So 1, 2, 3. 1, 2, 3. Do you see my shape starting to form this big yellow cube? Now that I've made the 3 height lines, I've got to finish the length and the width. So 1, 2, 3, and 1, 2, 3. There is my one giant yellow cube. The next step will actually be to show it in yellow. So here come my colors. I'm going to use the color yellow, and I'm only going to do the outline of this cube, but I'm going to trace all of the dimensions. So the cube has a height of 3. So I'm drawing those in yellow. Then let's say I want to work on the length. It's 3 long here, 3 long here, and 3 long here. And then it's a cube, all sides are the same, so the width is 3. 3 long here. Three long here, and 3 long here. That is my one large unit cube. So I'm halfway done. I've gotten it drawn. Part 2 is going to be to decide how many of those little green cubes would fit inside this. Can you see now why I chose to work with that denominator of 3? What it does now is it helps me see where the 1/3 cubes would fit into this. If the whole base is 3, then 1/3 of it is just one section. So one little green cube would fit right there. And the next green cube would fit right there. And the next green cube right there. So if I call this the length, 3 of those little green cubes fit across the length. Now let me take a look at the width. Because it's 1/3, 3 of them are going to fit inside the larger cube. So 1, 2, and 3. That means for the width, 3 cubes fit. Now for the height, it's the same thing going up. I've already got 1 cube at the base of the prism, so another one would fit here, and another one would fit right there. So the height also has 3 cubes. I'm going to go ahead and outline those in green just to visually help me see. These are the smaller 1/3 size cubes inside. So there's a green cube right there, and there's one right here, and one right there, and I'm just going to outline all of the edges. And across the length, it fit 3 times as well. And for the height, there were also 3 cubes. Now, I could technically go in and draw the other cubes, but I don't need to anymore, because here's what I figured out. 3 would fit in the length, 3 would fit in the width, and 3 would fit in the height. Now I'm ready to transfer to my piece of notebook paper. I can go back to number 1, and I can write the full formula for volume is length times width times height. And I found that 3 green cubes fit in the length, and 3 in the width, and 3 in the height. So multiplying using order of operations, I move from left to right. 3 times 3 is 9. And then I just rewrite the problem. And then I finish solving by multiplying. So 27 cubes would fit inside the giant yellow cube. If I look at how I visually solved that, if I counted how many of these actually fit inside this, I would get an answer of 27. My last step is just to put a number 1 beside this visual so that when Miss Burton looks at it, she can see the visual and then the mathematical solving. For number 2, I am going to immediately start with the dot paper because it's the same type of problem, but instead of it being 1/3 inch green cubes, they're going to be 1/4 inch. Notice, because of this fraction, because they're 1/4 inch, it will make my life a whole lot easier to draw that big yellow cube as 4 wide. Let's try that together now. I'm going to start with a height. Make sure I give myself plenty of space to come up later. 1, 2, 3, 4. So there's 4. And then I'm going to do the length of 4 and the width of 4. And once again, I'm choosing to make this 4 lines long because when I go to find those green squares, it just makes it easier to see how they fit in. So on the length and width, the height both comes up 4. And then I begin connecting the vertices. And I make sure that I finish the cube so that it is 3-dimensional. And then I'm going to go ahead and outline it in yellow. This is brain crossing. Both the drawing and the coloring help me understand what's happening in the problem and to visually see it before I get ready to mathematically calculate it. So now it's time to figure out how many of those smaller green cubes can fit inside. And because they are 1/4 of a larger cube, I can imagine 4 of those pieces fitting into my larger cube. I'm actually going to go ahead and draw these in green. So with the length, there would be 4 cubes across because they're 1/4 in size. And with the width, there would be 4 cubes across. And with the height, there's already 1 on the base of the prism. And then so there are 3 more added to the top. And I'm going to label my dimensions. This helps make my visual stronger. There are 4 green cubes across the length in the base of the prism. For the width, there are also 4. And for the height, there are 4 more. And this is problem number 2. So now I am going back to my notebook paper to write out problem 2. I'm going to write the formula for volume again because repetition, repeating a skill, moves it from your working memory to your long-term memory. So volume is found by calculating the length times the width times the height. And so the length, I found that 4 green cubes fit inside the 1 yellow. The width had 4 and the height had 4. I'm going to multiply across. 4 times 4 is 16. And then I just rewrote my problem. And then 16 times 4 is 64 cubes. So I finish with my labels and I circle my answer. So if I look at my visual, if this were really 3D and I put all these little green cubes inside the big yellow cube, 64 of them would fit in here. Take a look at number 3 and 4. They're very similar problems. We're finding the volume. In this problem, we have the 1 outer cube, and we can see the little cubes have already been packed inside. In problem 4, we have the outer rectangular prism, but we don't actually see those individual cubes. Now, we've done a lot of visual practice in 1 and 2. So in 3 and 4, we're going to focus on the mathematical, the formulas. The length times width times height. Or if you're thinking of volume as just area that's become 3D, we're going to find the area of the base and then just multiply that times the height. So let's go to our notebook paper and work on problem number 3. Once again, we're going to practice writing the formulas. This time, let's go ahead and write both of them. If you look at each individual dimension, you have length times width times height to find volume. And if you think of area, you find area by calculating the base, and then you multiply times the height. So in problem 3, it was a cube, which means every side or dimension was the same, and that was 1.5 inches. So 1 1/2 times 1 1/2 times 1 1/2. Oops. Whole number 1 right there. Now at this point for solving, you have multiple options. You can multiply fractions, or you can choose to make these decimals. I'm going to go ahead with fractions, and I'm going to make these all improper fractions. 1 1/2 is the same thing as 3/2. And that makes my multiplication easier. Because when I multiply, I'm going to multiply the numerators. 3 times 3. I'm going to skip a line so I keep it clean. And 2 times 2 is 4. And then I bring down what was left. That was 3/2. So I'm going to multiply the numerators again. 9 times 3 is 27. 4 times 2 is 8. Last but not least, I need to move that from an improper fraction to a mixed number. So 8 will go into 27 how many times? If you said 3, you are correct. And that would make 24. Well, out of 27, when I use 24, I only have 3 left. So out of the 8 pieces, I had 3 left. And then I can't forget my labels. These were measured in inches, and because this was volume with 1, 2, 3 dimensions, it's inches cubed, or cubic inches. Now, if you had done this with decimals, you will get the same answer. You'll just get it in decimal form. If it's given to me in fractions, most of the time I like to stay in fractions. Easier for me just to solve, keep it in the same format. If I do the other formula where I'm thinking of area as the base, I would have already multiplied length and width together. And I know that made 9/4. And then the height was still 3/2 tall. So the multiplication problem becomes the same at this point because you get 27/8. And when you make that a mixed number again, so it doesn't stay improper, becomes 3 and 3/8 inches cubed. So if I go back and look at my text, if I look at these green cubes, 3 and 3/8 would fit into this larger cube. Problem 4 is the last problem that we are going to work together. It's a little different because this is a rectangular prism, but it's not a cube, which means the length, width, and height are not all the same sizes. It is very possible to draw this figure and to calculate how many smaller cubes would fit inside, or what the volume of this is. However, that would be very time consuming and you would have to pay attention to a lot of details. So visual is not wrong here, but it's not the most efficient method. This is where the mathematical formula is going to become very helpful. So let's switch over to notebook paper. And now notice this is the first time on our sheet that we have basically gone all the way to the bottom. There's no way we can fit all of 4 here, so we're not going to cram it in. We're now going to go back to the right-hand side of our paper, and across from where number 1 started, we will work number 4. And let's use the formula for volume of length times width times height. On the rectangular prism in number 4, the length was 14.8 meters. The width was 4.5 meters, 4 5/10, and I'm multiplying that times the height, which was 3.5 meters or 3 5/10. Now, because these are in decimal form, I could switch to fractions, but to stay consistent, I'm going to keep my problem in decimal format. So I'm going to multiply 14.8, 14 8/10 times 4 5/10. Now, I just paused the video and I worked out this decimal multiplication myself. I got 66 and 60 hundredths. If you need help with your decimal multiplication, make sure you stop me. Let's go over it together. So this was just the first part of the order of operations, so I'm going to bring down the second half, which was multiplying that times the height. So basically I calculated the area of the base, and now I'm multiplying times the height. I'm going to pause the video again and work this out. Please do the same for yourself. And when I did my multiplication of the base times the height, I got an answer of 233 and either 1/10, or you could say 10 hundredths, because that's technically what I got. I did get that 0 at the end. And the measurements were in meters, and volume is calculated in cubic meters because of the 3 dimensions. So you can see why for this problem the mathematical is more efficient, because you would have had to draw this complex rectangular prism and then to have counted 233 smaller cubes. Remember, if you have any questions over decimal multiplication or from problem 3 fraction multiplication, make sure you call me over. The last step now would just be to make sure that there are holes in your isometric dot paper, to line up those holes, and then to staple your 2 sets of notes together, both the mathematical and the visual. And this is the end of lesson 13.4.